And then your calculator, where we did it the other way, your calculator got 0.6004. Why do you think we're off? Why do you think we're off by that much, Matt?
Rounding.
What?
Rounding.
Rounding. We did round off error. We had to round our z-score so we could look up on the chart. So there's nothing wrong with it. They're going to know. They will know whether you used your calculator or your chart. And notice that it doesn't matter which one you use, you're still going to get the same answer. Okay? So the last thing we need to do is write that sentence. Okay? So now we just need to write a sentence that I can't fit in there because I write so big. 60.0, and it doesn't matter if you put the 4 or the 9. You guys, either one of them is correct. Of applicants. You guys, I'm really sorry at home if you can't see what I'm doing. So 60.09% of applicants score between a 500 and a 700. We always have to put it back in that context of the problem, no matter what, you guys. That will lose you a point automatically. Okay? So now, how's everyone doing? Are we good? You guys at home doing good? Okay. And you guys can see? Okay. Okay, so now we're gonna do C. C now, notice that they give you a percentage, right? If they give you a percentage, that means that we're gonna do an inverse, which means we're gonna start with, we're gonna look up our area on our chart. So we're gonna look in here instead of a z-score, okay? So we're gonna work backwards to find that observation now. So we're working backwards to find the 500 or a 700. But our normal curve is still going to stay the same because we're still in the same problem. We're still going to start with the same normal curve. So what minimum score would a student need in order to score better than 77% of those taking the test? So 77%, you guys, is a percentile. So that student wants to be at the 77th percentile. So we're going to draw another normal curve because that is what we do. Right now we are in the business of making normal curves. I did that one a little bit better this time. So we know at 544, that's 50%. We know at one standard deviation out, this would be 647. How much data lies below 647? How much data goes below 647? It's on an empirical rule. I think it maybe starts with an 8. 84. So we know somewhere between 544 and 647 should be our observation. This is 84, this is 50, so we're going to put it somewhere right here. And we want to know what that score would be to place at. So we want 77% of our data to lie right there. That's what we want. I always give an idea, you guys, so I know if I get a score that is less than 544, I did something wrong. If I get a score that's greater than 647, I did something wrong because I know that my score should be between this 100 points, okay? So we're going to use the chart, and then I'm going to show you how to use your calculator. So we're looking up 0.770. We're looking up 77%. You want to get as close as possible. I found it whenever you guys find it. So we're looking up. So you guys, we're taking our chart. It would be in the book, the blue book, or on the chart, and we're looking up 0.77. And so I found 0.7704, okay? Okay. Okay. What did you guys get for your Z-score? I found 0.7704, and I got a Z-score of 0.74. Is that what you guys got? Do you agree with that? Is there anyone in here that has no idea what I just did? Okay. So my Z-score is 0.74, X minus 500 over 103. Yes, it would be. You guys at home, it is 544, not 500. I just have 500 on my brain. Thank you. Thank you for correcting me. Okay. Now, how do we do this? Do you guys remember? Yes, exactly. Algebra. So we're going to do 103 times 0.74. You guys, you cannot stop talking to me all of a sudden now. 0.74 times 103 is 76.22 equals X minus 544. I'm going to add 544. Paige, I know that you asked me about work. You don't necessarily have to show, like the adding and subtracting, but you have to show the score, okay? Like you have to show how we set it up, and then you can get me an answer. Anybody can do that, okay? You don't have to show this math work, but you do have to show the Z-score setting it equal. You don't have to show anything else, okay? And then X equals 620.22. So the minimum score a student needs in order to score better than 77% of those taking the test is 620.22. And yes, you're going to include the decimals. Is that what your question was going to be?
I was going to ask, since it's a score, can you technically have
Nope. Yes, you can. And that is what they want. Because this is continuous. Because if it wasn't continuous, if it was discrete, then we couldn't do a normal curve. So, yes. It's just a matter if they round it up or not. But everything's going to have things would have a decimal just because. So that's what they would need. If we were dealing with people, it'd be a little different, but this is a score, so we can have decimals. Just look at your grade book and all your tests that you guys haven't had that, but Schoology puts decimals into the grade book. Like Schoology doesn't round the grade book. You know that, right? So like if you get a 36.37, that is what Schoology takes over into Schoology, over into Focus. It's really funny. Okay. You good? We good at home? Everyone understand this? Okay, because I want to skip the next one. I want to do a different one. I want to do the Wessler adult intelligence test. I think that's how you say it. Wessler? I don't know. I mispronounce things all the time. Okay, so we've got mom and daughter. We got mom and we got Sarah, okay? They're going to take this intelligence test because they want to see who's more intelligent, Sarah or the mom, okay? So, and as we all know, children are always more intelligent than their parents, especially 18-year-olds. 18-year-olds are always smarter than their parents. Just ask any 18-year-old you've ever met. They are always smarter than their parents.
True.
Yes, so true, right? I just want you to know 49-year-old women are smarter than their parents too, but I digress. So, what we're going to do is they've taken this test. So, for the 20 to 34 age group, the mean is 110 and the standard deviation is 25. For the 60 to 64 age group, the mean is 90 and the standard deviation is 25. Sarah is 29, and Sarah scores 135 on the Wessler test, while Ann scores 120. Just so everyone knows, Ann is the mom. Okay? And who has the better score relative to her age group? So, you guys, always a picture is always good. Like, just a little sketch would be perfect. But what would be even more perfect is this is the Z-score. Sorry guys, I got distracted. Okay. I'm talking loud too. Okay. So we're going to do Sarah and we're going to do Ann. You guys, a quick little graph would be nice, but if you're going to do that, if you're not going to do that, then you have to show this. So we're going to do a Z-score because our Z-score will tell us just as much. I love a picture. I think a picture is really important because a picture is worth 1,000 words. So Sarah is 29 and she scored 135. So on her test, the mean is 110 and the standard deviation was 25. Ann is 62 and she scored 120 on her test. The mean was 90 and her standard deviation was 25.